Now let's take it about one by one. So stateless packet filters, because those are going to be implemented by ACLs, it means that traffic control is going to be achieved on a packet by packet basis, because an access list is not aware of sessions or flows. From the access list point of view, each packet is going to match the ACL, and the router or the device performing the filtering has to take an action, drop the packet or allow the packet. So, but the router doesn't keep track of the same packets, of all packets within a session, to say, oh, this is the second packet of a session, the third one, the fourth one, or so on. It's going to treat each packet individually and allow it or drop it based on the ACL rules. And in general, this is going to be a feature of a network device, a router, or a switch, or a firewall. We're going to see exactly why is it going to be also be used in a firewall, but not only on a device or on a switch. So the stateless packet filter is not a device dedicated platform. Even if you use IP tables on Linux, it's still a feature of the, let's say, operating system. It's not a dedicated system to do only firewalling. And because we use access list, it means that the traffic policies can be built based on the layer 3 header, source destination IP and protocol, the layer 4 header, which means source and destination port numbers and protocol, and likewise you can also match on the TCP flags on all of them. I've added there a couple of them, like the SYN, ACK, reset. You can match on pretty much all TCP flags on FIN, on URGE, on whatever. So as I was saying, because those are going to be classic ACLs, we have two types of ACL, standard and extended, and we can actually implement, we can implement the packet filters in 3 variations. So before we go there, just to make sure everybody is on the same side with the stateless packet filter or just regular packet filter. So like for example, if I'm going to put an access list inbound in here, inbound, which let's say it is going to just, for the sake of it, is going to permit all traffic, just permit any, let's say. So if I'm going to have a session between router 2 and ACS 1, it means that when router 2 sends the first packet, packet number 1, router 3 is going to match that packet against the inbound ACL, and it's going to allow it because the ACL has a permit any in there. It's going to allow the packet. And once the router 3 has routed the packet, then it has forgotten about ever seeing it. Then router 2, of course, sends the second packet from that session, destined to likewise ACS 1. 3 says again, oh, I got a new packet inbound on an interface where I have an inbound an inbound ACL applied. Let me inspect the ACL and take action. Likewise, it's going to be sent allowed because the ACL says permit IP any, and so on. So basically, that's what is stateless. It means that the router or the device performing the filtering, it receives a packet, it matches the packet against the ACL, it's going to take an action, drop or permit. If drop, then drop the packet. If permit, then route a packet and forget about it. Next packet shows up from the same session, but the router is not aware of that. That's a session. It's going to treat it. It's going to treat each packet individually. Receives the second packet, matches it against the ACL. It's going to match on a permit statement, routes the packet, forgets about it. So we have 3 variations of the access list. It's going to be a RACL, which stands for router of access list, which means because the router in general, in most cases, is going to have only layer 3 interfaces, it means it makes sense that the RACL is going to be applied as a feature on a layer 3 port. There we go. So the RACL is going to be an IP filter applied on a layer 3 interface. That's why it's called a router of access list. A VACL stands for VLAN access list, and is going to be an IP and or non-IP filter applied at the VLAN level. I'm going to speak just about the IP part of it. So with VACL, you can filter both IP and non-IP like ARP or SpanIT or CDP or LLDP or whatever, or so any kind of non-IP protocol can be also filtered with VACL, and VACL is going to be applied at the VLAN level, not at an interface level. And then you have the packet, which stands for port access list, which means that can be either an IP and likewise and a non-IP filter, which is going to be applied on a layer 2 interface this time. So even the naming convention tells you exactly where you're going to apply the access list. And now, why the VACL supports only layer 3, only IP filtering and not non-IP filtering? Because at layer 3, I'm speaking about IP only. Everybody runs only IP. I'm not running any other layer 3 protocols like AppleTalk or like IPX or whatever. I mean, maybe there are some isolated cases in the world for sure that they still run other layer 3 protocols, but mostly we're going to speak about only IP, so that's why it's going to be IP filtering only for the VACL. While the VACL and the PACL, they can filter also non-IP traffic, because the filtering is applied at the layer 2 level, either at the interface level for PACL or the VLAN level for VACL. And because at layer 2 I have also non-IP protocols, then there we go, those two filters can also match and filter on non-IP traffic. So I'm saying all of these comparisons because, as you've saw throughout the whole week, as we were speaking about examples, commands, or more specific, let's say more specific terms and technologies, then as I was saying in the beginning of the class, I don't want you to memorize things. I want you to try and understand why with the VACL I can do only this, and with the VACL I can do some more. It has to make sense. So the stateless packet filters, they don't support nowadays requirements for providing security at the edge of the network, or not even in the core, because they lack application level gateway capability, so they cannot inspect the layer 7 header. They cannot prevent layer 7 attacks, which is kindly nowadays pretty much all attacks are happening at layer 7. And is also not aware of the session concept, thus it cannot prevent layer 4 attacks either, because it cannot keep track of the session states, which is very important in a TCP session, because a stateful firewall, as you're going to see, is going to keep track of the session state of the TCP, especially, of course, is more useful in TCP traffic, because TCP has the sequence numbering of the packets while UDP does not. And also it's going to add a lot of management overhead. It's very difficult to deploy effectively when more than 2 zones exist, because you're going to have to, if you have like 3 or 4 zones and you want to do filtering with an ACL, then because of the fact that the ACL filtering is unidirectional, then you're gonna need to go and do a lot of filterings back and forth, and you even may do in the end a lot of mistakes, because you're not gonna keep track of which, or you're gonna lose track of which traffic has to be allowed in which direction to begin with. But we're going to see that those are still going to be used, the packet filters, in other use cases, but in general not at the network edge, where you would want another kind of filtering, which is going to be the stateful packet filtering.